Mobile apps, sports cars, skyscrapers, and Swiss watches. Um, they have one thing in common. People always see their beauty in how they look like or how they behave. But in most cases, people won't care about engineering hard work, algorithms, engine parts, or internal construction. My name is Mirek. I lead mobile department in Azimo, and I will tell you the story about building what is unseen, but what will make our users happy in long term. This is a quote from one of emails from Azimo's CEO, Michael Kent, and it shows a way we approach product development. Important part I highlighted says change being the only constant, and it tells everything about the situation in tech industry. And it leads to the main goal for us as an engineers. We need to be able to ship fast as we can, to bring new value to users in many short iterations instead of big ones, which sometimes takes months. And because shipping fast is the only way to learn fast, also from our failures. And the more answers we have, the higher quality of our product or our solution we deliver. But to make it work, we have to remember about something else, our source of learning, data. Because we can go really fast, but without data, our success really depends on luck. And data-driven development doesn't mean that we don't have vision. Actually, we absolutely have vision, but even if we spend days or months on TechCrunch or the next web, and our product covers all the newest technologies. We have application for smartwatch, we built assistant for Google Home, or our application supports payment with Android Pay. It really doesn't matter if we lose, let's say, 50% of our users on, for example, registration form. And this is where data is needed, because our ideas are based on our knowledge and our feelings. In case of Azimo, it's a team of about 100 people. So there is absolutely no chance that we always will know the best option or the best solution for the people. So we can just suggest the future or show the possibilities to the user, but the word of users will decide if they want to use or if they like to use our app. And let me give you a simple example. A couple months ago, we had an idea to implement brand new fantastic onboarding in our app, which should work like a chat. So application should greet new user and should tell how it works, what it does, how cheap we are, and what else we can do. But this kind of onboarding should give us better personal relation with every new user. And actually, I believe in this so much that I spent almost 2 weeks tweaking animations on recycler view and pushing the limits of this view control. But then we started analyzing the data, and we realized that for big part of our users, this was the last screen which they saw. So we tried something simpler. This screen was implemented in about 3 or 4 hours. And results are noticeable even on this slide. And even if we believe in close relation with our users, it was just our feeling. And in this particular case, data showed us that we are wrong. And it was the fact. So we had to accept this. it doesn't mean that data and vision cannot work together. Actually, it's quite opposite. And those guys know this very well. Ed Catmull, president of Pixar Animation Studios, in his book, showed the way how the vision and goals can evolve in time. At the beginning, let's say that we have our vision after 1 year from now. And this triangle symbolizes that over the time, our focus is bigger on this goal. But it also means that we see less opportunities around this unflexible triangle bounds. So instead, to not miss any better opportunity, we should focus on something closer in time. Let's say something doable in 3 months from now. And after that time, there is a chance that our vision will change a bit. But it is completely okay, because we are still closer to our main goal than 3 months before. And the same after next couple months. We still can see vertical progress, but we don't limit ourselves with unflexible triangle bounds. And in result, there is pretty big chance that we not only reach our goal, but also we will go completely out of bounds, depending how much open-minded we will be, but also how flexible was our engineering team. And now we can see why it's super important to be able to ship fast. Because shipping fast means how much new opportunities we can give to the business. And now I will give you a couple advices what we can do as an engineers. First of all, I know that it's super boring and everyone knows about this, but we should never ignore testing automations. And probably this is the most important thing in our work. This is our situation when we started mobile app development in-house. MVP version of our app was almost ready, and our contractor provided us tens of thousands lines of code with just one unit test. This one was actually generated by Android Studio. And when we asked this company why they didn't care about unit testing, why they didn't provide this, they said that they didn't have enough time to do this. But I think that the problem is that they misunderstood what fast delivery means in software development. This company spent about 5 months on development, and when they would need to provide this application, the code, together with unit test, they said that it would take about 1 month more. What can be a lot, especially for startup, but at that time, our product wasn't ready. So we had to add some new features, remove the other ones, and we estimated this change to no more than 1 month of additional work. But the problems started when we had to make sure that our application still works without any issues. It resulted with additional 2 months of work for iterations between developers and external QA team, because we didn't have any unit test, so actually we didn't have any test. So no one could trust us that the application still works without any issue after our changes. And it means that every new internal build should have full manual test performed, what in our case takes about 1 full day of work of our QA team. It means that finally we released our first version after 7 months. And at that time, about 1.5 years ago, every new version was released in about 1 month. Today, we release new version in every week. So it means that we have at least 4 times more chances to adjust our product goals and our vision. And to make it happen, we minimized manual testing. Currently, only new features are tested by our QA team, and it's done only once. During development, because right now our QA team is part of development team, to reduce time for iterations between developers and testers. Because manual testing is extremely slow. We always have to build our application, deploy it to our device and click through it. What is also super boring, because all the time we do exactly the same. Open the app, log in, accomplish any flow, log out, and we do it at least 100 times a day. So after 1 month, it can be really frustrating for everyone. Also, imagine this simple example. We want to show pop-up to ask user for a rate. And we need to be sure that application was installed long time enough on his device and the flow was successful. So to test this code manually, we have to open the app, log in, then we have to change the date on our device, open the app again, and accomplish flow successfully. And hopefully everything works fine. But anyway, we wasted about, I don't know, 2 to 5 minutes for manual testing. Or we can write proper unit test, which validates those conditions, and probably it won't take more than the 5 or 2 minutes which we spare on manual testing. And unit test written once will always check if our logic works correctly. And it won't take more than a couple milliseconds each time. This is our basic tool set for unit testing. It's pretty simple. It's just JUnit, Hamcrest, and Mockito. And this is really what you need to start. Something to check assertions, something to mock external dependencies. And of course, what is probably the most important here, we should have proper mindset. Unit testing must be a part of development. So if you know that, if you feel that, you will start adjust your tests, adjust your code automatically to be testable. Because writing a test should be something natural for you. If it's difficult, you should probably consider this as a bug in your code. And probably the most important thing, we should test the logic of our app, not SDK. Maybe it's not always true, but we should assume that all external dependencies, including Android SDK, are already well tested. And our goal is to make sure that the logic works correctly. And of course, it interacts correctly with external dependencies. To make it real, we have to move as much business logic as possible outside of Android components like activities or services. And this kind of separation makes our code more testable, but also what is important, now business logic, it's pure Java code, what means that it can be developed and understood by programmers who don't even know Android, who are not even part of mobile team. And of course, there are some tools which makes Android unit testing easier, like Roboelectric, for example. And in general, I'm not advocating against using those tools, but I believe that tools like Roboelectric should just help us with testing edge cases. I mean, the code which doesn't have proper abstraction yet. This example code presented on Roboelectric website, which validates that the text is presented after we click on button. And this is exactly the same test when we assume that activity presenter is responsible for logic and it's separated from Android SDK. And you see the difference. It's much simpler because all we have here is just action and validation of the result, and that's it. Of course, there is a lot of different ways how we can separate our code from SDK and have well-structured project. And Google on its GitHub account published some Android architecture blueprints with example projects which use different libraries and tools. And most of those examples are implementations of model view presenter architecture, and there are examples with data binding. There is Uncle Bob's clean architecture concept. For those who love working with Android SDK, there is example with Android loaders and content providers, and a couple more. Personally, I would recommend the example with Dagger 2, which is used for dependency injection. Yeah, dependency injection is a software pattern which probably is very well known by everyone here. So I will go through it quickly. In practice, we have two ways of providing needed objects to our class. We can build in them into our class or pass those dependencies externally. And the second approach on the left side is named dependency injection, and it of course makes our code more modular and less coupled. And it means that, for example, if we would like to change implementation of user store, which is used in our user manager, or provide mock object for unit tests or integration tests, we will be able to do this without changing the implementation of user manager. Of course, as long as new implementation of user store will have the same interface. But the biggest problem with dependency injection is that without any framework, the complexity of objects creation and configuration is pretty big. And this code shows initialization of presenter for this simple screen, which does actually one thing. It connects with GitHub API, and it loads the list of repositories for given username. And this is where Dagger 2 can help us, or any other dependency injection framework. The same code for our example can look like this one when we use Dagger 2 for dependency injection. And what Dagger 2 really gives us is clear separation between code construction and between objects construction and configuration and its usage. So there is no magic in this. We just have separated classes named modules, where objects are created and configured. Then those objects are provided on demand to the place where we want to use them. And this example module class, which provides all needed dependencies to for API connection in this case. But let's move back for injection process for a while. Our presenter object is provided when we call inject method explicitly. And Dagger 2 cares about that after we call this method, all annotated fields, all annotated with inject fields are already provided. And somewhere under the hood, Dagger looks for objects in his object graph, or if objects are not yet created, it calls modules provides methods. And what is also super important, Dagger 2 can inject not only objects, but also providers and lazy wrappers. And here's the difference. Direct injection gives us intended object explicitly, directly from object graph or from modules. Lazy injection delays our object until we explicitly call for this object, of course after injection process, when we explicitly call get method on lazy wrapper. So when we ask for the object for the first time, it's delivered from object graph, from modules. But when we do it again, the same instance will be returned because it's already saved in our lazy wrapper. And the last one is provider injection. This one will return intended object from object graph every time when we call get method, when we ask for this. So the difference between lazy and provider is that the provider doesn't store latest instance of returned object. So every time we call get method, it's taken from object graph. Some time ago, we also started using RxJava observable injection, and this is not something what Dagger supports by default. We of course need to add RxJava dependency to our project, but then all we have to do to inject observable is to wrap our lazy object, lazy wrapper, with observable. For example, with observable the defer method, and where it could help us. Let's assume that our application has a lot of dependencies, which has to be initialized during application launch. So we need to set up, I don't know, Crashlytics, some analytics tools, REST client for future API calls, and we need to do this we need to do this in our application class. So doing this on create method in application probably will significantly increase launch time and time which user has to wait to see our application for the first time. When we wrap those dependencies with lazy wrapper, we can delay the injection to not block the initialization process. But the problem still exists because we just delay the injection, but when we try to load our dependencies, they are still blocking main thread in our application. So when we wrap lazy objects with observable, we can move some dependencies loading to background thread to not block user interface. And thanks to this, user will see our application a couple 100 milliseconds faster. So we will be able to show him at least a part of user interface. And you know, it's still better than showing him just a splash screen. Besides that, Dagger can make our code a bit cleaner and better organized. For example, thanks to local components, we can get rid of all constructor calls in our code. So for example, it's pretty readable. But you can see here two constructors which can be moved outside of this activity class. And instead, this code can look like this one. Both adapter and linear layout manager are already injected from local graph, which is currently bound to activity. So we have activity object which is used to initialize those classes. And also because of it, we can be sure that all injection happens in one time. Not like here, that for example, adapter is created a bit later than presenter. And here we have another example, adapter class. As you can see here, we check object type twice here. So this unnecessary duplication and can lead to unnecessary bugs in our code. Instead, this code can look like this one, and the logic which checks the view type of our item is placed really where it's needed, because on create view holder method already has view type, so you know we don't need to check it again. We could do this because we injected map of factories for every given view holder type. And in Dagger, we have something called multi-binding, what gives us a way to inject map of objects. What can be useful, for example, in collection views, which have different view types to avoid additional logic in view adapters. And there is much more what Dagger gives us. We have compile time, code generation, and validation. And there are also custom scopes, a way to have single instances, not only as long as application process is alive, not only singletons, but for example, we can have single instances as long as user is logged in. Of course, during one application launch, or as long as screen is visible. And there are also a couple good solutions for memory usage and for performance. But for this, probably we could prepare different presentation just about Dagger 2. Instead, you can check my GitHub account. There are a couple projects called Dagger 2 recipes, which among the others show how to build user scope, how to perform asynchronous injection with ArcsJava observable, how to build multi-binding, or there's also basic application built on top on Dagger 2. And I will post this link on my Twitter after my presentation. Besides clean code and good architecture, there is another important thing which can help us a lot. Those are automations. I remember very well when we started building dependency injection and the continuous integration and continuous delivery system in our company. At that time, complete build of our application took about 5 minutes on my machine. So when I was asked to publish new version to Play Store immediately, I was in the middle of something. So I changed branch to master, but I was too lazy to perform clean on a current project. So without checking anything, I pushed new version to Play Store, which looked like this. Yeah, this was the most minimalistic Asimov version which we ever pushed to Play Store, and our CEO wasn't very happy because of it. After this accident, we decided that the only trusted person in our company will be this man. And currently every new build, no matter if it's for internal testing or for Play Store, is prepared by Jenkins. But also we had another requirement. And as a company, we believe that everyone can work from any place he wants. So we need to be able to build a new version from every developer's machine, no matter if it's in Office or not, if it has access to our VPN. And there was a tool very well known by our iOS developers, which meets those requirements. It's Fastlane. And this is a tool to automate building and releasing Android and iOS apps. And this is our first lane, which built internal debug version, mostly for developers to see results, for example, from code analysis or unit tests. And first step is obvious, but as I mentioned, we very often forgot about this. Clean the project, then compile it. Next step are unit tests, because even if unit testing is part of development process, developers very often don't do this before committing, because it was just one line of code, or because they just unit tested the class which they worked on. Next one, code coverage report, because we all love statistics, and actually in our company we have monthly challenges between Android and iOS teams. Currently we lose. Those numbers are not real. Right now, Android has code coverage on 63%, yeah, but still we lose with iOS team. Then the last line is lint check, and lint is really powerful tool which we shouldn't ignore because it can tell us about most common mistakes in Android development, about unused resources or missing resources. For us, it's especially helpful with translation check because our app is translated to 10 languages and it's done by non-technical people. So sometimes they don't know, sometimes they don't remember how, for example, formatter arguments should look like, especially when we provide translations in the same time for Android and iOS. Another important thing is SDK check, because we develop our application on minimum SDK version 21 to not deal with multidex and ProGuard. But our application supports SDK 16, what means that sometimes we use classes which were not available on Android, on older Android version. And yeah, this is another main issue caused by our lint check. Our next line, which builds release candidate app, it does exactly the same at the beginning, like internal debug version. But of course, there is different branch and different build flavor. But then, when our build is complete, we send this to Crashlytics beta, which is used to distribute beta version across the company and analyze bugs and basic behavior. Then, when our beta build is complete, we push notification to our Slack channel, because there are some basic informations about the app and the release notes. Because sometimes when we pushed new version to Crashlytics beta, no one saw this, so people waited, I don't know, half a day to start testing. And the last step in this lane is uploading to another tool. It's NimbleDroid, and this is the tool to analyze our working app for performance and memory issues. And I highly recommend it, especially if you have no tests for performance or for application launch time. And besides stack traces and memory leaks analysis, you can see, for example, comparison charts between your application and the most known application in the world. So it's not that bad in our case. We are a bit slower than Messenger and WhatsApp, but we are a bit faster than Twitter, for example. And our last main lane, it's simple. Again, it does exactly the same what internal debug version, of course, different branch and different build flavor. Plus, at the end, we use Fastlane supply plugin, which, among the others, can sign our APK file, can push it to the Play Store, together with store descriptions and what's new sections, and we can push it to alpha or beta channel or even official channel on Play Store. And our project has also a couple other lanes, like end-to-end test suite, and this lane is composed from smaller test packages which can be performed independently, because sometimes we want to test the whole application, the whole platform, but sometimes we want to test, I don't know, just authentication process or transaction creation process. The biggest problem with this test suite is that it takes about a couple hours. That's why we currently work hard on something called test sharding, which will give us a way to perform those steps from this whole lane, those tests simultaneously on many emulators in the same time to decrease overall testing time. Currently, we have some problems with official Android simulator because we cannot launch more than 2 simulators. But for example, Genymotion gave us a way to launch at least 5 or 6 simulators in the same time on MacBook Pro. So we are able to perform those tests, let's say, 5 times faster than currently. And there is also a lane for static code analysis. For now, it's unplugged from build lanes because whole analysis process takes about 10 minutes in our case. But in return, we have a list of potential bugs in Java code, which cannot be caught by lint or by unit tests. And for static code analysis, we use Facebook Infer plugin, mostly because it works across different platforms, so we can perform analysis of Objective-C, but also JavaScript, and we have the same interface in results from this analysis. And as I mentioned earlier, all those lanes can be performed on every developer's machine, which has Ruby and Android SDK installed. And the role of Jenkins is just to collect the results and show them in more friendly way, but also to not block developer's machine. And there is, of course, much more solutions and tools, but everything really depends on our needs and requirements. And this is the final advice I would like to give you, because at the end, our customers won't care if we use Dagger or clean code architecture under the hood, because they care about final product. And this is really what we should focus on. That's all. Thank you. I will post some links and this presentation on my Twitter right after this presentation. And if you have any question after this presentation, I will be here the whole day. Or you can reach me on my email or Twitter account. Thank you. And do you have any questions? The mic is coming.
First of all, You done? Yeah. So first of all, thanks for the talk first. And I was going to ask, why do you separate your static analysis lane from, I know you see, I've seen you using Facebook Infer, but why aren't you using things like PMD or find bugs or check styles in the same lane as the debug or the release candidate one?
For now, as I said, because it's a bit too long. And currently, it doesn't look very well. There are no tools which shows the results from static code analysis in friendly way. We are converting this to results which looks pretty similar to unit test results, but it's not yet what we would like to have. Yeah, we plan to have this in our at least nightly builds or something like this, but maybe later. But we are not saying no.
And yeah, the second question was about UI testing. So you mentioned about unit testing. Do you use any Espresso?
Sure. That's why our coverage in unit testing is on 60 to 70%, because we use Espresso. We have a lot of integration tests, but in our particular case, with our app, we have a lot of end-to-end testing, because we work with many external partners, and actually unit test and even integration test didn't give us all needed answers, because we have a lot of issues with external providers, we have issues with external APIs. That's why we focused on manual testing in the first stage, and now our QA team is working hard to automate those manual testing by end-to-end testing. But yes, we are using Espresso for both integration test and for end-to-end testing.
Cool, thanks.
Okay, thanks. I wonder the problem with Espresso that like sometimes it's really rare that tests in mostly in older devices are just not passing because something in this device, simulated device, it's really rare. But if you have like hundreds of tests and multiple languages, and I know you do because you have it, and you are testing it each contribution, I think like we did in Travis, it's like it's kind of often that one test will just randomly fail and all the builds will be like red. So it's really annoying. This is why I moved to unit tests. Do you find some solution for that?
Yeah, flakiness of tests will always exist. That's why we have dedicated developers to maintain those tests. And yeah, we still have those problems, but it's about, let's say, 1 or 2% of our tests failing, sometimes on some of devices. That's why we check those tests again manually, and this is our only solution. Of course, we have some abstractions for Espresso. We perform full cleanup of data store, shared preferences, everything. We even have special activity just to initialize integration or end-to-end tests, to clean up everything, to have, you know, let's say 1 second to prepare for testing. It helped us, but yeah, the problem still exists for both simulators and devices. Sorry,
Nice.
I have no answer. We still
Yeah,
fight
but
with
it's extra annoying because if there would be some problem that is happening like very, very rarely, you wouldn't notice it because you know that there is a flakiness in this test, so it's really bad in Espresso.
It is, but that's why we
Thank you.
have a lot of you know, additional logs which can tell us if it fails because of environment, or it fails because of, you know, developers failure.
Do you think it makes sense to fail the build if the number of warnings or errors on lint increases?
Could you expand?
For example, someone make the commit and the number of warning increases by the commit. Should the build fail? So you know, the number of warnings is not increasing. So the
No, it really depends, because, you know, sometimes lint errors are not so, you know, important, but yeah, we want to have no more than 10 errors in lint checks. And yeah, before we release application, we of course check every single error from, you know, from static code analysis, from lint checks. But we don't want to fail build, because, you know, even if we have some warning in lint, we can still perform unit tests and integration tests and, you know, everything in our build process. And we have also APK file, because we can then publish this to you know, to our beta channel. And in the meantime of fixing those warnings, our, you know, testers can start manually testing new features, or can start working on test automations.
okay, and the second question, maybe you mentioned it, but do you use MVP or other similar pattern?
Yeah, we use MVP, but I think that it's not MVP like it's described in Wikipedia or any. This is our MVP, which meets our requirements. That's why I'm not talking exactly about MVP and how to build presenter and how to build model. I think that, you know, everyone here has his own, you know, solutions how to do this. If it works, and it works for a year or two, it's okay.
But so maybe you have some example on your GitHub. How do you do it in Asimo?
Not exactly Asimo, because it's a much bigger project, and some solutions works only if your code base is bigger. We can simulate this, but I have very simple GitHub client on my GitHub. But if I would apply all patterns from our production app, probably programmers couldn't see the benefits from this implementation until they see the real usage. So that's why it's hard to show this on Hello Earth examples on GitHub.
Okay, thanks.
So I have a question about the time complexity, or if you could estimate how long will it take you to build app of complexity like Asimo from ground up, in comparison to the time that it took this other team, and it wasn't complete. It didn't have like Dagger and other things. How long will it take you?
You
to-
mean
to
build the code from scratch, or
Yeah, to build from the ground up with all this bells and whistles like Dagger or Java, and how much overhead will it give to the time needed to build?
I think that the overhead is just at the beginning. You need to build your very first application component in Dagger, and you have to set up environment for unit testing. Of course, you have to agree with the team how you want to unit test and things like that. But in daily basis, I don't see any overhead, because we see benefits from having loose coupled code and having unit test and everything's from here. So actually, I rewrite Asimo app from scratch. It took about 3 months. It was about 1.5 years ago, and yeah, this 3 months was an investigation because we didn't go forward in that time. But thanks to this, currently, as I showed, we are able to push every version in every week. I mean, every version is meaningful for product, because sometimes we push new version to the store every 2 days because of any bug or something. But every week we can release application which is fully tested, fully analyzed, and everything. So those 3 months paid off, I think.
Thanks.
Thank you for your great talk, and I have one question, because you do a lot of things in Asimo. Thank you for sharing your lanes and everything. Are you planning to do some repository mining to get some knowledge from your Git repository? Because now it's kind of popular to say that the repository mining thing is the future of programming.
Yeah, I think that over the time I or we will publish more and more solutions, and
Okay.
yeah,
Okay.
actually we really believe in contribution in open source, because
Okay, but I'm talking about repository mining, because there is a lot of information in Git repository, in your Git repository, and people say that you can analyze that, and you can check if there is a dead places in your code, so you can strip that code out. And are you planning to do something like that?
actually, I think that probably you should explain me what
Okay, so
repository
maybe
mining means.
okay, so we can talk maybe after.
Sure,
that.
sure,
Yeah, okay,
sure.
cool. Thank you.
Cool. I think that there is no more questions. So thank you again.